I'd like to start with showing you this test setup. It was used to initially test whether the microcontroller could actually be programmed. This is a socket with a microcontroller in it. This is the final PCB without any components on it. How it came from the manufacturer. And this is it with components on it. There's still some free footprints. This is due to the DC to DC converters not arriving in time due to the corona crisis, the COVID-19 crisis. Now, I've set up a little test here. As you can see, this is still the Project Blue board in a half of a PS4 controller. If I turn this over now, I have used the pins from the joysticks, and I have broken them out into LEDs. So now when I press any button, we should technically get all the LEDs lighting up. You might notice that when I press the buttons, only 3 of the 4 LEDs light up. This is due to a connection issue or something on the board, or a test setup issue in the actual code itself. There are also some buttons like this one, the PS4, square, R1 and L1, which also have the same issue. Again, it's not a connection issue between the top PCB and the bottom PCB, since I checked the connections with the breakout pins here with these carbon pads. However, there were some other issues, like a missing level shifter between the USB port and the actual microcontroller, so that can't actually be programmed with USB right now since it's not 5V tolerant. Another problem was that the test LED, which was mounted here, was also a faulty pin. I haven't figured out what the problem is yet. So I've only recently figured it out after the report was submitted. So I haven't had enough time to actually implement the wireless control from this, but that is now just a matter of programming rather than the PCB not being correct. It is working perfectly fine. I think even the issue with the not working pins will be resolved after further testing. Here's the code I'm using right now. Oh, sorry. I have got the pin definitions up here, then some whether the inputs and outputs, pull down for the button pins, and then I'm just checking whether any button has been pressed, and if that's the case, the LEDs switch on, otherwise they're always off. Further things that can be implemented on that controller would be either the actual touchpad being connected, or it could be replaced with a screen like an LCD screen or an e-paper screen. The speaker has not been connected yet, that could be connected, and the rumblers also need a motor driver on the board, which can allow for them to be addressed.